Alright, so today we're going to talk about probability. And you might know a lot of this already, and that's great because now when we take it to the next level, you already have that solid foundation. So let's get started. Oh, we have Cooper rolled a 6-sided die. What are the possible outcomes? So on a normal dice, we have the numbers 1, 2, 3, 4, 5, and 6. And the definition of an event, that is a list or collection of outcomes. So if we have the event rolling an odd number, what are the outcomes that we could have that are odd? So 1 is odd, 3 is odd, and 5 is odd. So if we look at the formal definition of probability, it is the likelihood of an outcome happening. So if I would say, the probability of us returning to school this year is quite low. I'm not saying it's impossible, I'm just saying that it's not very likely. Now, when it comes to probability, we want to assign a number to it, and that number ranges from 0 to 1. And so I could then say, hey, the probability of us not going back to school is 0.8 or 0.85. Or you could word the problem differently and say, hey, the probability of us going to school is 0.1, 0.2, very low chance that we return to school. So be careful about how problems are worded when you're thinking about probability. So probability can be written as a fraction, like 1/3, or a decimal, like 0.33, or a percentage, like 33%. I tend to stick with leaving it as a fraction because I am prone to make mistakes on the calculator sometime, and it just is an extra point of error by converting fractions into decimals or percentages. But either way is fine. And like I said, when you're talking about probability, the closer that your probability is to 1, the more likely that the event will happen, and the closer your probability is to 0, the least likely it is to happen. We're going to focus today on something called theoretical probability. This is what you would expect to happen. So if I were to flip a coin, a fair coin obviously, we would expect that half the time we get heads, half the time we get tails. So we flip the coin 200 times, we would say, well, we should get 100 heads and 100 tails. If you have forgotten how to calculate probability, that is the number of success over the number of possible. So if we look at this example dealing with cards, we say, okay, you pick a card from a standard deck of 52 playing cards, find the following probabilities. Picking an 8. So this part right here, that's a short way of writing it. We're saying P for probability of picking an 8. So here we have our standard deck of 52 cards all laid out, and you can see that we have 4 8s. Okay, so the probability of picking an 8 would be 4 out of 52, and that can be reduced to 1 out of 13. So out of 13 tries, you should get 1/8. That's the theoretical probability. That is what we would expect. Part B, picking a red king. Well, if we go back to our cards, a red king, here are kings over here, and we only have 2 of them. So that would be 2 out of 52, which can be simplified to 1 over 26. All right, on the next page, the probability of a face card or an ace. So that means either one of these is a success, an ace or a face card. So let's look at our deck of cards. And face cards are cards that have faces on them. So all of these over here are face cards, or an ace. So we got to say, okay, how many do we have over here? How many of my cards are highlighted? And if you were to count them all up, you would get 16. So then over here, the probability would be 16 out of 52, which simplifies to 4 over 13. Now, letter D says the probability of a 7 or 8. So either one of those will be a success. Okay, so here's 7 or 8. And there are 8 cards that I highlighted. So the probability would be 8 out of 52, which simplifies to 2 over 13. And then the last example here, the probability of a red 7 or a black 5. So if we look at our cards, a red 7, so these are the only 2 red 7s, or a black 5. These are the only 2 black 5s. So there are 4 cards highlighted there. So the probability here will be 4 out of 52, which simplifies to 1 over 13. So out of 13 tries, I would expect one of those cards to be a red 7 or a black 5. Right, let's look at rolling some dice. So you roll a die, a 6-sided die, find the probability of the following events. Over here, I'm just going to jot down the numbers real quick. So the probability of rolling a 2. Well, there's only one 2. Or we can write it like this. There's only one 2. So it's a 1 out of 6 chance of rolling a 2. Rolling a prime number. A prime number is a number that is divisible by only 1 and itself. 1 is not prime, but 2 is prime, 3 is prime, and 5 is prime. So the probability of rolling a prime number is 3 out of 6, which simplifies to 1/2. And C, rolling a number divisible by 3. So the probability that your number is divisible by 3 is, let's look and see that we only have 2 numbers that are divisible by 3, 3 and 6, which simplifies to 1/3. And then the probability of rolling a 3 or a 4, oh wait, it's already written that way for us, so I don't need to do that. It is 2 out of 6, which simplifies to 1/3. Okay, so we're going to take these probabilities and use them in example 3 to figure out if we were to roll that dice 225 times, how many times would we expect each of these events down here to happen? So a 2, rolling a 2 on the dice. The probability of rolling a 2 from up above was 1/6. So we would multiply 1/6 times 225, because it's how many times we are rolling the dice, and we get 37.5. Well, that would round up to 38. So we would say about, whoops, let's zoom back out for a minute. We would say about 38 times. Then rolling a prime number, the probability of getting a prime number from above was 1/2. So then we would multiply 1/2 times 225, which would equal 112.5. So about 113 times. And then the last one, rolling a 4. So remember, the probability of a 3 or 4 from above was 1/3. So then we would do 1/3 times 225, and we get a whole number this time, which is 75. So 75 times. So we just multiplied the probability by the number of times we rolled that dice to figure out how often this would occur. Now, for example 4, let's read it first. You have an equally likely chance of choosing any integer from 1 to 12. Find the probability of the given event. So I'm going to write down these numbers all the way to 12. Oops, I skipped 7. Now, I want you to try these on your own, letters A, B, C, and D. So pause the video, try them out, and see if we get the same answers. Alright, let's look at these. These are the answers I got. The first one, a number less than 9. So you don't want to include 9, you want to include everything smaller than that. So that may be why you got a different answer there. For letter B, a perfect square. Remember, 1 is a perfect square. So we only have 3 perfect squares here. And a factor of 20. Remember, factors are numbers that you can divide 20 by and get a whole number answer. So our factors of 20 would have been 1, 2, 4, 5, and 10. So there are 5 factors. And then a 1-digit number, obviously a number that only has 1 digit. And then probability of 11 or 12, there's only 2 of those numbers. So hopefully this was a good review for you guys. Or if you learned all about probability, hopefully it wasn't too bad. So tomorrow we're going to move on and talk about a different type of probability. So make sure you hit the like button and subscribe. Bye.